We learned how to determine the molecular shape or molecular geometry using Lewis structures. But one important thing that you have to remember when it comes to longer molecules or molecules with higher molecular weight, by that I mean molecules that have 4 carbons or more. See, for example, 1 carbon, methane, pretty simple, tetrahedral shape, 109 degrees, bond angle, pretty simple. But when it comes to molecules that have larger number of carbons, say for example, if you had a butane molecule, right? And this molecule has 4 carbons with, of course, hydrogens around them, right? So if this is a butane molecule, think about rotation along this bond, say rotation around this bond, and in the class I will show you with models. So when these carbons rotate, this molecule will look like this, right? So it's the same molecule with a different position or with a different rotation around carbon so relative to one another. So in this situation, the relative geometry is like this, the relative bond angle is like this, but in this situation the relative bond angle is different. So how did this happen? This happened because this carbon the bond here is easy for the carbons to rotate, so you can twist those carbons around that bond. So these two, and like this there are hundreds, they are known as conformers. So these two are conformers, and these two are known as conformations. This is one conformation of this molecule, this is the other conformation. So these two are conformers. Okay, now as long as any two structures have identical connections between atoms, they are conformers. Okay, and they represent the same compound no matter how you draw the structure. So the same compound will have conformers. Okay, sometimes you have to see two structures mentally, okay, or with the help of models to see if they form conformers or not. Again, we're gonna practice this and then try to understand conformers and conformation.